Recording. Well, so today we're going to discuss about the high availability concepts that are available in SQL Server. There are quite few high availability techniques in SQL Server. There is mirroring, lock shipping, replication. Let me make a note of those. High availabilities in SQL. We have database mirroring, lock shipping, replication, clustering, and always on. These are all the high availabilities in SQL Server. What exactly a high availability mean? Let's assume we have a server which is located in New York, and assume that server contains some medical information like a healthcare department, like the patient's information of any hospital. And unfortunately, if there is any disaster happen in New York and there was some power outage for some time, maybe for an hour or two. So during that time, if anyone who is trying to get a treatment from this hospital couldn't get his information, the patient records couldn't found. And in the same way, the banking databases, or you can pick it as ATM machines. If we already know that each and every city was spread across all the ATMs. So let's assume you have got a ATM in nearby your location, and you frequently go and swipe your card to draw your money. And if that machine is out of service for any reason, then obviously what we do is in general we try to find other ATM which is nearby, and we swipe our card to get money. So in the same way, in SQL Server, high availability is something like we want to keep our database always available for the users. Assume that your ATM machines were restricted, your ATM machines will only work in particular time, let's say from 9 a.m. to 6 p.m. If that is the case, then all the users or all the customers of that bank will be frustrated. If I have to withdraw an amount, maybe morning in 7 or after 6, then what would be my option? So all the customers of that bank will try to go for other vendors or other service providers. So in current market, we need to keep our databases or data or service always available for the users or for the customers. So in the same way, in SQL Server, we have these 5 techniques which we can use to keep our database always available for the users. So each and every technique, each and every topology which I have listed here will work in a different way. Database mirroring will work in a different way, and lock shipping will work in a different way. Replication, clustering, always on. Each and every topology has its own advantages, and at the same time they have got some limitations. So let us try to get into more detail about each and every topic. The first, we start with the database mirroring. So let me show you some pictures over here. Okay, assume this is my server. This is my server 1, which is a production. So I have a database in the server. Assume this is my database. I call it as db1. So I have a SQL instance, that is server 1, and in that instance I have a database called db1, and we always try to set up high availability for all our critical databases and critical applications. So in my case, I have db1 and have one more database, db2, on this instance. Okay, so I have two databases on this instance, db1 and db2. Among these two databases, I was requested to set up a database mirroring for only one database, and that is for db1. Might be that could be a more critical database, and the management need a high availability for the database. So in case of mirroring, what we do is we select one of our server which is located in a different data center. Okay, assume this my primary server is located in New York, in New York City. So what I do is I can set up this server in New York City itself, the secondary server, but that doesn't make sense. If something happens in New York City and if there is some disaster happens, I should be in a position to bring my database back to users from some other location. So I bought a server from a different location, possibly maybe in a different city. Maybe I choose it as I just picked up as a random city, is California. My secondary server, I name it as a server 2. I've got this secondary server in California city. So now the server is ready, the secondary server is ready. We need to set up the database mirroring. So before we proceed of setting up database mirroring, there are certain prerequisites which we need to be take care. There are certain prerequisites we need to look into before we set up database mirroring. So the prerequisites are the first prerequisite is both the servers should be both the servers should have identical versions. Both the servers should have identical versions, and in each and every high availability concept we call with a different terminology. In database mirroring we use some terminologies, we use some Jordan words. In log shipping we use some different Jordan words. So coming back to this database mirroring, whatever the server, whatever the main server you have got, we call this server as principal. So we call this server as a principal, and whatever the database we are configuring for mirroring, we call this db1 as well as a principal database. So the whole server, this is a main server, right? This is the original server. So we call it as a principal server, and the database which we are trying to set up a high availability for database mirroring. So we call this DB1 as principal DB. And our secondary server, and the secondary server, we call it as a mirrored server. We call this as a mirrored server. So these are the terminologies we use in database mirroring. And once you have both the principal and mirrored server with identical versions, then the next prerequisite is to have your primary your principal database should be in full recovery model. The principal database should be in full recovery model. So before you set up database mirroring, you need to go and check the properties of this database to see whether it got a full recovery model or not. If not, you have to change that recovery model to full. So sorry guys. So I was telling about the database the recovery model here. So if you notice that that the database has got either a simple recovery model or bulk log recovery model, the first step, we need to change that recovery model to full. Then only you can add this database to mirroring. And then after, these are the two prerequisites, the version number and the database should be in full recovery model. And once you are happy with the prerequisites, then I will try to point out the steps that we need to do for setting up the mirroring. So we need to take a full backup and immediate log backup of principal DB, that is from server 1. So the first step is we need to take a full backup of this DB1 from server 1, and immediately you need to take log backup as well. And once you are ready with the full backup and log backup, copy those two backup files onto server 2 and restore them with no recovery option. That's one more important point. Restore the full and log backup, both backups, full and log backup with no recovery option. Please do remember this point. We have to restore that full and log backup onto the server with no recovery option. So obviously we get a database over here on our secondary server, that is on our mirror server. Dinesh, we are discussing about database mirroring. So I have got a DB1 here. So I have restored the full line log backup, and this will be in restoring mode. As we are restoring the full line log backup with no recovery option, so the database on mirrored server will be in restoring mode. So this is the initial thing we need to do. And once the database is available on your secondary server, now we go on to our primary server and we configure the mirroring. So I will try to show you the architecture here, and once we understand that, I will show you the demo. So assume the database mirroring has been set up now. So how it works is, don't worry, I will take you through the demo, how to set up the entire thing. Let's say there is an application. This is an application accessing your principal database. So when this application or the users who are trying to connect to their database, they obviously come through application. No users will directly connect to a management studio and execute the queries. So always users, they interact with the SQL database through an application. So they do some sort of application filling, or they do some updates to any records, and once they submit, those records will be directly updated on your SQL database. So when a user issues any command from the application, before it goes to a SQL server, it comes to a log buffer. Let me pick the right, okay, probably this one. Okay, so this is a log buffer. Let me write over here. So when any user executes any query to SQL server, it initially come into the log buffer of this server 1, and from there the transactions will be pushed onto the LDF file of this database, and upon committing and issuing a checkpoint, the data from the LDF file will be flushed to the MDF file. So the first point, it comes to into log buffer. So in mirroring, what happens is, when an user, let's say user is trying to insert 100 rows. The user is trying to insert 100 rows on this database, on a table. So those first 100 rows information will be logged in the log buffer. So once the log buffer has got that information, so as we have set it up database mirroring, what happens is this log buffer okay. Right. So once we get that 100 rows information, the first thing, it will be available in log buffer before it pushed onto the database log file. So if we have set up a database mirroring, how it works is, the log buffer, what are the data we have got in the log buffer, that log buffer will be pushed onto the secondary server log buffer. We call it as a log cache. So whatever the data that was available on a primary server, from a log buffer or log cache will be directly pushed onto your mirrored server DB1. Okay, so at this point we have got data at two sites, on mirrored server as well as on principal server. But here there are two modes how you want to commit your data. Do you want to commit your data first in principal and next in mirror, or do you want to commit your data first in mirror or later in principal? So we have two modes, that is synchronous commit. So we can call it as availability modes. One is synchronous commit and the second is asynchronous commit. We will have these options when we configure our database mirroring. When you go for synchronous commit, that means whatever the data you have got into your log buffer on your principal that will be first pushed on to your mirror, and there those 100 records will be inserted on your database on your mirrored server. And once the records been inserted, this server 2, that is your mirrored server, will send an acknowledgement back to your principal server. Okay, so once the transactions been executed, there will be an acknowledgement sent from mirror to the principal. Mirror will send an acknowledgement saying that okay, what are the data have got from principal. Mirror will say have inserted those 100 records, and now you can go ahead and commit the transactions in the principal. So that is what the synchronous commit. So once the data being committed in the mirroring node on the mirror database, mirror server will send an acknowledgement to the principal server saying that I am done with my work. So once the acknowledgement being received to the principal, then principal server will commit the transactions and save it into the MDF file. So as long as the data is not committed over here, the same data will not get committed. It will still be available in the log files. So this is an synchronous commit. And using this synchronous commit, we can have automatic failover. We can get an automatic failover. When I say automatic failover, that means if this server if this server 1 goes down at any time in the midnight where none of the DBS are available, but still there are quite users accessing this database across different locations. Maybe this database has got users across different regions, different time zones, but you don't have DBAs supporting following the sun. So in that case, if my principal server goes down, then the applications that are connecting to this instance will obviously get fail, right? Because the server is down. And DBA, someone has to alert us, or if you have any monitoring tools, you need to get an alert, and we wake up on the night and we try to fail over the databases from principal onto mirror. So in order to rule out that one, we can have an automatic failover. Automatic failover is still possible in database mirroring. If something goes wrong with your principal server, you don't need to wake up at midnight. you can set it up automatic failover so that your SQL Server itself fails over the database. So in order to get an automatic failover, we need another server. We need another server, and you don't need to have an identical version. It should be any version that works. And this server, we call it as witness server. So the first one is a principal server, which holds the original database, and the second is the mirrored server that holds the copy of the database, and the third server is the witness server, and the responsibility on the roles and responsibilities of this witness server is this witness server will continuously monitor your principal server database and as well as your mirrored server database. The work for the witness server is only to monitor your principal database and your mirror database. If it knows that your principal server is down, then this witness server will inform your mirror server saying that, oh, your partner server is down. It is the time now you have to take the responsibility. So the witness server will go back to the mirror server and tell that your principal server is down. Now you have to take the responsibility. So once the mirror server get that information, the database state till now it was in restoring mode, right? So it will be changed to online. When a failure happens, the roles will be changed. The restoring mode database will go into online and it becomes as principal. And the database on your server 1 which was down, probably it might come back after 10 minutes. So once this server comes back after 10 minutes, this will go into restoring mode. This will go into restoring mode and acts as mirror. So just it will swap the roles. Whatever we have got a principal role here earlier, as it was down and a failure happened, so the principal will become mirror and the mirror will become principal. So once you have got this database into principal, that means it can be accessible by any users. So this all can be done with the help of witness. If you have a third server, that is a witness server. If you don't have a witness server, then we have to manually fail over the databases. And again, this database mirroring is at database level. If you have got 10 databases on an instance and you are asked to set up database mirroring, you have to set up 10 database mirrorings, one for each database. That's for us synchronous commit, and automatic failover can only be possible if you set up with synchronous commit. And for the other mode is the asynchronous commit. Asynchronous commit in the mean it's quite opposite to synchronous commit. In asynchronous commit, once it gets the records information, the data over in log buffer, your principal server, what it does is it will send a copy to your mirror server. That's it. That's the work done by your principal server. Your principal server will not wait for any acknowledgement from the mirror server. Whatever the data the principal server is getting, it will push a copy to your mirror server, and it doesn't bother whether it is executing or not. It try to go and commit the data in the principal. So that's the only difference in synchronous commit and with asynchronous commit. And the other way, synchronous commit is good to have that at any point of time your principal database and your mirror database will be consistent, will have same data at any point of time because it is a synchronous commit. But whereas in asynchronous commit, there is a possibility that your mirrored server will be lagging behind your principal server. And when we go for synchronous commit and when we go for asynchronous commit, there are two reasons. If you have to go for synchronous commit, the reason would be you might be expecting a automatic failover, or you want to have identical copies on both the sides. In case of disaster, you don't want to lose any second, 1 second data. So in that case, you can go for synchronous commit. We also call it as high availability mode. We can also call it as a high availability mode. And the second one, asynchronous commit, when we go for asynchronous commit is probably your second server is located in a different geographical location, maybe not in US, it might be located in Europe. Okay, so in that case, every time what are the records that are coming into your principal database 1, it has to send a copy to your server which is located in a different geographical location. So it has to send data across the network, and it takes certain time, and you don't want your users to be waiting on your principal database. Let me give an example. As an end user is executing a query to insert 10 records in this principal database. He is expecting that query should run in 10 seconds. I'm just giving an example. The user is expecting his query should complete in 10 seconds. And see what happens in two different modes. If we have a synchronous commit, so the first 10 seconds it will take on principal, and the second and in another 10 seconds it will take onto the mirror, and there will be a time to transfer the data from principal to mirror. So assume it might be around 3 or 4 seconds. So in total it take around 23 to 24 seconds to execute that query if you go for synchronous commit. But at the same time, we'll have same data at both the sides. But whereas in asynchronous commit, whatever the data, the 10 rows information got into principal DB, it will be executed immediately, and the result will be sent back to user saying that 10 rows were committed, and probably he might be satisfied because that query executed in 10 seconds. And internally SQL will send a copy to the mirrored, and mirror might take 10 seconds or 20 seconds or 30 seconds or even 1 minute. Your principal server is not going to wait for that. So that's the only difference. If you locate your mirror server in a different geographical location and you don't want to wait for an acknowledgement, then obviously you can go for asynchronous commit. And between these two, how these two databases will be talking to each other. I mean, I said the log buffer or the log cache will be transferred across to server 1 from server 2, and once this server 2 becomes principal, then the data will be transferred from server 2 to server 1. So this log cache will be transferred using endpoints. The data will be transferred through a TCP IP port. That's the endpoints, we call it in database mirroring, and the default port number or the default endpoints for database mirroring are 5022 and 5023. These are default endpoints for SQL Server. So once you set up database mirroring on a server, this port number will be used to transfer the log cache from one server to the other server. So now we have set it up a database mirroring with automatic failover. So we assume this server is down now. So what happens, as this is an automatic failover, your witness server will go back to your mirrored server and tell that your principal is down. So it is the time now to take a responsibility. So as soon as it gets that information, this server will act as a principal and the database will come online. Now The users who are still trying to connect to this database will get errors because the server or the database is down. So we need to inform them that the database is online on this server too. So the users may probably there is some disaster happen on server 1 and it might take around 2 hours to recover. The system team gives you a ETA of 2 hours to get this server back to online. So we can't just sit idle for 2 hours. We can't ask the users to wait for 2 hours, right? So what we do is we provide the server 2 information, the connection string information to the application, and and ask them to connect the server 2 instead of server 1. So applications have to manually configure or manually change their connection strings whenever a failover happens. So this is all about the database mirroring. So any questions at the architecture side? Okay, let us try to configure it now. I've got server 1 and server 2. First of all, we need to make it simple. Mani, please let me know where you got confused. You can unmute and speak out.
Hello,
Yes, Mani.
can you hear me, sir?
Yes.
Yeah, I mean, after the part where it says, this one, synchronous commit and asynchronous commit, I totally lost from there. I mean, the difference between them.
Yes, synchronous commit. If you set up a synchronous commit property in database mirroring, what happens is the data first will be committed on your mirrored database, and once it's been committed, your mirrored server will send an acknowledgement to your principal database, and upon receiving the acknowledgement, your principal database will commit the transaction. Okay?
Okay,
And
okay,
in asynchronous commit, your principal database will send the data to your mirrored server, and your principal database will not wait for any acknowledgement. In asynchronous commit, it will just send a copy to the mirrored server. That's it. It's work done. Your principal server or your principal database will go ahead and commit the transaction. So
mm-hmm.
that's
Okay,
asynchronous.
okay. And what about the numbers you have written down there, 5022 and 5023? I didn't get that part.
They are endpoints. We call it as a TCP port numbers for this database mirroring. Having said that, the log buffer or log cache information will be copied from the principal server to the mirrored server, right?
Yeah,
You got that point,
yeah.
right?
Mm-hmm.
So that log cache information will be transferred through these endpoints, through these
Okay.
ports.
Mm-hmm.
And these are the default ports for database mirroring 5022 and 5023.
Okay.
So any more questions? There's a question from Kaushik. Do you have to change the port number now to do mirroring? No, having said that, these are default port numbers. SQL itself use these port numbers automatically. But if you don't want to use that port numbers and if you want to use a different port number, still it is possible. Don't get confused about SQL port number and database mirroring port number. SQL default port number will be still 1433. We are not talking about that one. This is very specific to database mirroring for pushing out the data from the principal onto the mirror. There should be some channel, right, to send out the data from one server to other server. So that is what using these two port numbers. So any more questions? Kaushik, did I answer your question? Kaushik, are you there? Guys, can you hear me? Oh, sorry. I haven't scrolled down the chat window and I'm still looking over there. Okay. Do we set up both modes for database mirroring? We can only select one mode. Either you have to go with synchronous commit or asynchronous commit. You can't set up both modes. Okay. When primary becomes mirrored, do we need to change the port numbers? It's not required. SQL itself takes care of that one. Okay, let us try to set up a database mirroring now. So before that, I need to check the service accounts for the two servers. I'm just changing the service account to a domain account so that it would be easy for us to set it up. It's rmvp_sql. If your SQL services are running on local system or NT authority, we might face issues when we configure all these high availability in SQL Server. So it's always good to have a domain account. So I'm not sure whether I remember the password for this. Let me test it. Perfect. So let me change this one. Okay. So I create a new database. Assume this is my principal and this is my mirror. Okay. So I'm creating a new database. Or else I name it as DemoDB. And the prerequisites we need to check. The both versions should be same. We can see here it's 11.0 and it's 11.0. It doesn't matter about the next 4 digits because my first instance I have applied service pack 1, but for second instance haven't got a service pack 1. It still works, it doesn't matter, but the version should be identical. If your source is 2008 R2, then your mirror server instance should also be 2008 R2. If your principal is 2012, then your mirror should be 2012. And then after, the recovery model should be full. So we have created a database that's a demo DB. Okay, now let me create a table in this database. tbl underscore test with id integer and name varchar of 100. Okay, I've just created a new table without any data. So if you go back here, where it is, paint here. So we need to take full and immediate log backup of principal database. So go to this principal instance, and this is my principal database. So take a full backup. This is a full backup. And immediately take a long backup as well. Log.trn. And now the next step is restore the full and log backup on your mirrored server with no recovery option. So this is my mirrored instance, and as of now I don't have any database with name called DemoDB. So I will be restoring the database on this instance. I have to restore the full backup first. There is a DemoDB. And other mandatory thing is we need to have database name identical. The database name should be same on both the servers. So I leave it with the same name and go to files. I just relocate these files and go to options. Here we will be choosing restore with no recovery. And on top of this, I will be restoring a log backup. So browse the log backup file. And here in options, we still need to select restore with no recovery. That is what required in database mirroring. The mirrored copy will always be in restoring mode. We cannot read data from the mirrored copy. So we have restored a full backup and log backup with no recovery. Then we can go to the principal database, right click on it and go to task, and here you see a mirror. Select this option and click on configure security. From now we are going to set up database mirroring here. So click on next. The first wizard it gives you, do you want to include witness server to get automatic failover? As of now, I don't have a third instance to include here, so I will be choosing no. But in your organization, if a requirement to have an automatic failover, then you need to get a third server that can be used as a witness. So you can go on to next, and this is a principal server instance. So you can just cross check whether the instance name is right or not. So this is my principal server instance, and then after you can see this is a port number. So 5022, which is a default port number. And then you can just go on next and provide the mirrored server instance details. So my mirrored server is SQL 2012 instance, and this is a port number for used for this server. And you can go on to next. And here you need to provide the service accounts. The service account for the principal and the service account for the mirror. You need to provide those service account names here. And you can just read out for SQL Server. Is everyone having disturbance from my side? Okay. How is it now? Do you still have disturbance? Okay. So what I'm saying here is we need to provide the service account names of principal and service account name of the mirror. Okay, you still have issues with my audio? Okay. I'm not sure. Everything seems to be fine at my side. Hmm. Okay, how is it now? Any change or you still have that voice disturbance? Still. Can one of you try to log off and log in to check? Okay, any difference? Still have issues with my audio or is it good now?
So can you hear us?
Yes, Mani.
Yeah, your voice is like really breaking. I mean, there's some, I
All the
guess
time?
there's a problem. Yeah, no, even now, yeah. Maybe you want to reconnect to your list, log out, log in, something like that.
Okay, I can do that, but if I disconnect it, I gonna lose the
Oh,
recording session. Just
okay.
trying to manage it. Okay. If it is
Oh,
still having issues, then I will try to rejoin. I'm just closing this call, and you can quickly join back again.
Okay.
Let me type over here.